Yes.
So yeah, potential for renewable energy, its exploitation and energy consumption patterns at a regional level, results from the ESPON LOCATE project, which has been coordinated by colleagues from OIR, the Austrian Institute of Spatial Planning. And the part that I will present has been elaborated by a team from TU Wien and Fraunhofer ISI in Karlsruhe. So when we have a look at the share of different sectors in total final energy consumption, we see that there are, of course, differences between countries, in particular regarding the role of the building sector, also the role of the transport sector. And this was a starting point to better understand what is the territorial dimension of implementing a low carbon economy approach in different parts of Europe and in different types of European regions and cities. And so we had two parts in this project. First part deals with energy consumption patterns and the potential to produce and use renewable energy sources. So this was the quantitative part, which I will present today. And there has been a qualitative part as well, dealing with energy relevant regional competences and regional room for action and their interaction with EU and national levels of legislation and policy making. So yeah, I already said I will deal with this quantitative part in my presentation. We elaborated quite a number of data sets, and I want to first explain briefly which type of data sets we produced. Also a little bit give an impression about uncertainties related to these data sets. And then just pick a few out of them to, I would see it as a teaser and to understand a little bit better also the type of conclusions that we can derive from this. So from this table, you can see that we have split the energy demand into heating and cooling, other end uses, and transport. And then into the different parts of the building sector, in particular, also distinguishing residential buildings, public and private non-residential buildings, then the sector agriculture and forestry, and the transport sector. And transport sector also by the different modes. Most of the data sets were developed on NUTS 3 level. These are the ones presented in dark green here, and some data sets on a lower level of spatial disaggregation, either NUTS 2, NUTS, or also country level, where we are simply also not so reasonable. Like, for example, a renewable electricity share. Not so reasonable to allocate to display on NUTS 3 level, to my mind. We covered EU28 member states plus Switzerland, Norway, Iceland, Liechtenstein, EU28 status 2017, so including UK. And we covered the years 2002 and 2012. The study was completed in 2017, so 2012 was the latest available data set. Now we have 2021, so it's a little bit outdated already, but I think some patterns remain quite stable, in particular when it comes to building related energy consumption. Regarding renewable energy potentials, we covered wind, solar, hydro, biomass, geothermal, tidal, and wave. And I will select, as I said before, a few of them and present some results on maps. A few words on the methodology to develop the spatial allocation of consumption patterns. Basically, we use data available on different regional levels, so from NUTS 0 to NUTS 1, NUTS 2, and NUTS 3 level, where different data on the building stock, on on final energy consumption by energy carrier in the different sectors is available, also economic activity data, and we let's say used the lower level data to break down the higher level data to the NUTS 3 levels. This, of course, implies some methodological questions and difficulties and uncertainties. I just want to pick out one example. For example, there is not really a consistent data available on the net floor area on NUTS 3 level, but we have floor area data available on NUTS 0 level. And we have data available on the economic activities, and so we see that there is some correlation between the net floor area per capita on NUTS 3 level, and we can derive some correlations between the value added per capita on NUTS 3 level and the net floor area per capita, and from this also let's say extrapolate some information relevant for assessing the total building stock data and related energy consumption. So with that, I want to come quickly to some selected results, and I start first with the final energy demand for space heating, hot water, and cooling in residential buildings. So this map shows this final energy demand for space heating, domestic hot water, and cooling in residential buildings in megawatt hour per capita. So megawatt hour of final energy demand per capita in the year 2012. And becomes quite obvious that there is some link to climatic conditions. But we can also see that there is a certain discrepancy between Western and Eastern European countries. And I also want to point out, for example, this clear cut between southern France and Spain, is something that we actually where we see also limitations of the method. So we use national data and break it down by using local data to the NUTS 3 level. But obviously, some of this local data is not sufficiently well represented in the final result. So this also shows the uncertainties related to this type of data. And now we can compare this data with the growth or let's say with the development in the 10 years from 2002 to 2012. So on the left-hand side, it's the same map as we have seen before. In absolute terms, megawatt hour per capita, the consumption. And on the right-hand side, we have the change in final energy demand in this sector in this 10 years period, again in megawatt hours per capita. And it's quite small, so I hope you can see a little bit all the green cells, all the green NUTS 3 levels, or light green to darker green, they are all negative. So we see decrease of final energy demand for space heating in substantial parts of Europe due to thermal building renovation, also replacing of heating systems, more efficient heating systems come into place. And we see some countries, in particular in Eastern Europe, also Italy, with some increase, the blue regions, the blue areas. And this is mainly due to a change in the supply of energy services. So related floor area and also change in comfort. also change in heating systems, by the way. Yeah, so this and in Eastern Europe, we see that this change in the supply of energy services led mainly to this increasing energy demand. A few words on the validation and also to understand better, let's say, the reliability a little bit of our approach. We thought a lot about and analyzed different indicators to break down NUTS0 data to NUTS3 data. And we could do it either by a pure population-based indicator, or we could do it by a pure number of dwellings-based indicator, or we could use, as we did it in the end, by using a more comprehensive indicator, weighting different impacts like floor area, number of dwellings, also differentiating between total and occupied dwellings, construction periods, and so on. And these are the comprehensive indicator, the red bars. And for the residential buildings, and the shaded red bars is the comprehensive indicator for residential and non-residential buildings. And we see, and the graph basically shows the on NUTS2 level, because here we have better data available, at least for these selected NUTS2 regions, the deviation. And with the selected comprehensive indicator, we have a lower deviation, but still in some, so let's say plus minus 10%, or even a bit higher in some of the areas. So this is the approximate range also of deviation that we can see with this methodological approach that we took. Some further results for the final energy demand in road transport. So again, same unit as we had before, megawatt hour per capita. Here again, we see quite substantial differences, but obviously not due to climatic conditions, but rather due to different, of course, a lot of different reasons. But the most fundamental difference we see between Eastern European countries and Western European countries. And interesting enough is when we now again take on the left hand the status in 2012, and on the right hand map the change in final energy demand in this 10 years period from 2002 to 2012, we see the strongest increase. There is a tendency that those countries with already a high final energy demand in road transportation even had a stronger, had a strong increase in this 10 years period, whereas this was much less the case in Eastern European countries. Now the question is coming from the energy demand to the share of renewable energy carriers that is used in some of the end use sectors. So here I want to show just one picture or one sector, which is the share of renewable energy carriers for space heating and domestic hot water production of residential buildings. And here we see that there are some areas with a considerable share, so in around of 50%, so these dark blue ones, and but also a lot of areas, in particular in Ireland, UK, with a very low share of renewable space heating in residential dwellings. And in the 10 years period from 2002 to 2012, in general, the share of renewable space heating has increased by about between 3 to 10%, and in some countries, some areas even more. In particular, we can also see that there are some areas like Baltic countries with a very high share of renewable space heating, which is mainly covered by biomass. And looking at this 10 years development, we see that there hasn't been not really an increase, because this is already a long, let's say, tradition to use biomass for space heating, where there was not much increase, whereas in other countries like Italy and Scandinavian countries, much stronger increase happened in this period. A few words about potentials. Wind energy potentials have also been mapped on NUTS 3 region. Due to time, I will go more quickly through that. We can see that, of course, in mountainous areas in particular, wind energy potentials are much lower than closer to the sea. In coastal regions, the exploitation rate in 2012 is still quite low in most of the areas, but let's say in terms of this growth from 2002 and 2012, we see that almost the whole exploitation of wind energy potential happened in this 10 years period. And for PV potentials, the picture in principle looks similar. There are, let's say, there is of course the stronger north-south trend, but there is also there are also not 3 areas with a lot higher availability of space, potential available for space for PV generation, leading to a higher potential. We can see that the exploitation rate is strongly focused on a few countries, in particular, Germany, Spain, Italy, due to the national policies and also the growth in exploitation rate from 2002 and 2012 shows that this was really a very strong period of growth in PV exploitation. So, coming to a summary, I think a quite comprehensive data set has been elaborated on NUTS 3 level, of course, with also related uncertainties and limitations due to the methodological approaches, due to the availability of data as such. Energy consumption of space heating and cooling are mainly driven by climatic conditions, energy performance of buildings, which in general was increasing from 2002 and 2012, and the economic wealth and resulting levels of energy service, which was also increasing from 2002 and 2012, at least in some regions, and that partly outweighing the increase of energy performance. Renewable energy potentials show considerable variances due to the geographical and climatic differences. So regions with high wind energy potentials are in particular is quite well known: North Sea and Baltic Sea, northern France, Germany, Netherlands, Denmark, United Kingdom, Poland. The change in the exploitation of renewable energy potential from 2002 and 2012 was mainly triggered by national policies. And just one sentence about the qualitative analysis, although I was not really involved in that, but just to also highlight one thing, it showed as an exemplary result that the power of building a narrative of political economy linked to the idea of energy self-sufficiency. I put this here because at the same time, although we came to this conclusion, our colleagues doing this analysis came to this conclusion, I believe that this also changed due to the, let's say, higher awareness of climate targets in the past years now. Thanks. I took the opportunity to also add the link here, as Andrew did. I copied in short notice also the link to our project here and all the authors. That's it from my side. Happy to discuss some questions if there are any.